Jai Hind. Here is maths integration, definite integration problem. Integrate 1 to 16 tan inverse square root x minus 1 dx. So before solving this question, we are coming to thought. Thought is you are chasing the time. You are chasing the time, but missing out on quality time. You are chasing the time, but missing out on quality time. So it means our day should go in good way so that we can show our quality education. So this is the good problem. Integrate 1 to 16 tan inverse square root x minus 1 dx. So in this problem, this question is by parts problem and its limit is 1 to 16. First part we take one part, and second another part is tan inverse square root x minus 1 dx. So in this question, how we choose which one is the first part and which one is second part? The trick behind it, isolate. The trick behind is isolate. Isolate. Okay. So I means inverse, L for logarithm, A for algebraic, T for trigonometric, E for exponential. So here is inverse, tan inverse. So it is inverse trigonometry. So here we take inverse. Okay. Therefore, we choose this first function and one is second function. So this is the trick behind finding the which one is first function. Now double function integration formula, do you know? We write first as it is and integrate second one. So one integration of 1 is x and same second written as it is tan inverse square root x minus 1. Its limit is 1 to 16 minus, then integration sign 1 to 16, then differentiation. First second function's integration that gives us x and second function's differentiation. So differentiation of tan inverse x, its formula is 1 plus x square, 1 upon 1 plus x square. So squaring of this, so square root cancel out, so only square root x minus 1 will left. So this is the tan inverse x integration, but there is no tan inverse x, there is square root x minus 1. So square root integration is, so square root x minus 1 integration is 1 upon 2 square root x minus 1. Further we say inside there is not x, there is square root x minus 1. So its integration is, its differentiation is square root x minus 1 differentiation is 1 upon 2 square root x and dx written as it is. So this is by parts method integration. Now we see further solve. So first we write as it is, later we put the limit x tan inverse square root x minus 1 1 to 16 minus 1 to 16 integration, and now look, numerator has x, denominator has also square root x into square root x, it gives us x, because this plus 1 minus 1 cancel, it is square root x term and there is square root x term, so it gives us, okay. So square, now in the denominator term we also get 2, there is a bracket also, because 2 square root whole, this integration is 1 upon 2, 2 is outside, then square root x minus 1, so 2 bracket x square root x minus 1 dx. Numerator x, denominator x cancel out. Now put the limit in the here. First we put above limit, upper limit, that is 16 for x, and then tan inverse square root. Square root 16 is 4, 4 minus 1 is 3. Then we put minus sign, then 1 we plug in, so 1 into tan inverse square root, then square root 1 is square root 1 is 1, so 1 minus 1 is 0. This is limit is put. Now 1 to 16. Here we get only 1 upon 2, and then there is 2 times 2, so we get 4. 2 times 2 is 4. So we have here 4, and then square root x minus 1. There is whole square root also. So this is left term. Now to solve this integration, here the main trick is behind. We assume square root x equal to 1 plus t square. To remove this square, we assume square root x equal to t square plus 1. So differentiation both side, it gives us 2 square root x dx equal to t square differentiation is 2t, 1 differentiation is 0 into dt. Square root x value we again plug in, and then we get dx equal to, so 2 square root x we plug in here, t square plus 1 in square root sign into 2t dt. This we plug in here, and first we see here in the term, first term 16 tan inverse root 3. So tan inverse root 3 is pi by 3 value, so we get 16 into pi by 3, and here 1 into tan inverse 0. Tan inverse 0 is at 0, so it is 0, then minus, then 1 upon dx value we plug in, 2 square root t square plus 1 into 2t. There is not a square root because square root x is t square plus 1. So square root cancel out, only t square plus 1 is there, upon, and dt also, upon, there is 4, and in the square root x we plug in t square plus 1, and this minus 1 as it is we write. So plus 1 minus 1 cancel, only square root t square, it gives us t. 16 pi over 3, so this 0 eliminated, minus. Now limit, the value of limit, this is the interesting, the value of limit. If the limit was 1 for x, so we plug in the 1, square root 1 is 1, so 1 equal to t square plus 1. So 1 subtracting both sides, it gives us t equal to 0. So we get lower limit 0. Upper limit for plug in 16, square root 16 is 4. 4 equal to t square plus 1. So t square equal to 4 minus 1, 3. So t equal to square root 3. So square root 3. 0 to square root 3. Now look, denominator 4 and numerator 2 into 2 cancel out. So 4 cancel out. In numerator we get 0 to square root 3 t square plus 1. We get only left. Why? This t and this denominator square root t square is same, because square root t square is t, so t cancel out. We get only t square plus 1. Further integrate, integrate of t square is t cube upon 3, and one integration, its integration is t, and we'll put the limit 0 to square root 3 minus, and remaining terms we write as it is 16 pi over 3 minus t cube upon 3 plus t, and its limit is square root 3 to 0 to square root 3. Now plug in the value. So 16 pi over 3 written as it is t cube, it means square root 3 cube is 3 square root 3 upon 3, and t's value is square root 3 minus 0. 0 means nothing, so we eliminate it. So 3 cancel off numerator denominator. Square root 3 plus square root 3, it gives 2 square root 3, and 16 pi over 3 minus 2 square root 3 is our final answer. I hope you have understood. This is quite long, you are looking, but by practice you will perfect, and you can do very less in very less time. Okay.